So today we'll be solving this problem using the heat formula. So first let's read the problem given. Calculate the amount of heat released when 9.65 milliliters of water cools from 67 degrees Celsius to 47 degrees Celsius. Let's first write down the heat formula. This is Q equals M times specific heat times delta T. Q here stands for heat. M is for the mass of the substance. SH stands for the specific heat. Of the substance. And finally, delta T is change in temperature This is found by subtracting the final temperature, T final, minus T initial. Doing so will give you delta T. So going back to the problem given, we're trying to find the amount of heat released. We're given volume. We're also given the final temperature and the initial temperature. Now volume isn't part of the equation given, so what we'd like to do first is convert 9.65 milliliters to a unit of mass, which is grams. Because this is water, we know that the equality of milliliters to grams for water only is a 1-to-1 ratio. So 1 ml is equal to 1 gram. So the conversion table would look like this: 1 ml over 1 gram is 1 gram over 1 ml. So to convert this to grams, we start with 9.65 milliliters. Then we put milliliters on the bottom in order to cancel these out, and grams on top. So that is a 1-to-1 ratio. Milliliters cross out. Then we just multiply across. 9.65 grams of H2O. Okay. I'll just bubble this to show that, this is important. Alright, so from there, we can plug in the values into our heat formula. So we are trying to find the amount of heat released. So that's Q equals, this is our mass. So that would be 9.65 grams times specific heat of water, which in this case is 4.184 joules per gram Celsius. Then times T final, which in this case is 47 degrees Celsius minus 67 degrees Celsius, which is our initial. So 47 degrees Celsius minus 67 degrees Celsius. Alright, and from there, we can just rewrite this area right here first. Grams times specific heat. And we can subtract this 47 minus 67, which should give you negative 20 degrees Celsius. After doing so, to find Q, you would just multiply these across. This would give you negative 808 joules. We have 3 sig figs because when multiplying, you find the value that has the least amount of significant figures. As you can see here, 3 would be the smallest. We disregard the temperature because according to our professor. So this is our final answer.